anything. So it's pretty much a proxy server on all of your iOS clients. And Matt Thompson refers to it as he's the NS hipster guy, if you guys read him, as the most powerful and also one of the more obscure parts of the URL loading system. So why should we care? Well, almost everything in your application is a URL. All the stuff in your web views, calls to your backend, local file loading, if you're implementing caches, anything to do with caches, all the third parties and what exactly they're sending to their hosts. So an example of that might be, and this is a nod to Giorgio wherever he is about tests. If you're writing performance tests, you're not always sure whether or not they're failing or just slow. You can use URLProtocol to stub them and return responses on fly. URLProtocol can help with that. Or if a third-party vendor promises to never change his URL versioning scheme at all, but then gets a new domain, URLProtocol can be insurance that can get you around that. Or if a third-party billing framework or any random arbitrary third party is sending your users' locations to their remote server, URLProtocol can tell you that. And if you want to serve images to a web view that are stored locally or modify them in any way, you can't do that without URLProtocol, and that's true. So an example of URLProtocol, if we want to implement this, it's just 3 steps to do. And the first step is we subclass URLProtocol. And URLProtocol is not a protocol, it's a class, and we implement it by subclassing it. And we override 4 of the methods, and then we register it to tell with the URL loading system to tell Foundation that we're going to use our custom protocol to load URLs. So just simple subclassing of URLProtocol, and we're going to name our protocol myCatExterminatorProtocol. And we just inherit. And we override the first method, which is can_init. So this function, can_init, is called anytime a request is asked, it wants to be loaded. It'll pop down in here, and from this method we return whether or not we want to use our protocol to load that particular request. So if we pass true, myCatExterminatorProtocol will be used every single time for every single request for all parts of your application to load that. And so we only want to load, because we're not actually we're going to kill the cat, so this is a cat exterminator protocol. We only want to concern ourselves with requests that have things to do with a cat, right? So if it's not a cat, we're not going to use it. Then the second method that's important to override is canonical request for request. And this is called assuming can_init is returned true. We drop down, the request drops down to canonical request for request. And this gives us the opportunity to modify the request in any way we see fit. And then I'll show you, we can inject headers, we can do anything. It's important to return the request back to the URL loading system. So we're not going to screw with that, we're just going to return the request that we were passed. And this is probably the most important function that we have to override if we're going to extend our URLProtocol. Start loading. And it is crucial that we pass a new response to the URL loading system. Because if not, we'll just hang all requests and we'll never get responses. So it's critical that you create a response and pass it back to the URL loading system. And we do that so typically what you would have is a network, but here we are exterminating cats, so we can synthesize that response right here, add an HTTP header for cat status exterminated, and with that, we pass it back into URLProtocol did receive response. And so we communicate with self.client in a URLProtocol as a way to pass whatever response we receive, or in this case, create, back to the URL loading system. So when we pass in the response, that will be what comes out the other side in your task, your data task resumption. And I'll show you an example. And if, for whatever reason, we don't have a HTTP URL response, in this case, we always will. But if we don't, if the network fails, whatever, we have to pass the error back in. And then, secondly, we have to tell the URL loading system that we are done loading. And that is also very important. If missing that can lead to strange and obscure memory leaks and so on and so on. And the last the fourth and final function to implement URL protocol is stop loading, and that can be called if the user cancels a request that's in flight. In this case, we have nothing to do there because we're just killing cats very simply. And so the four methods, just to quickly recap, the first is can init, and that tells, we return a Boolean telling, should we load this request that is passed to us? The second is what request exactly are we loading, gives us the opportunity to modify that in any way that we see fit. We didn't in our example. The third is to start loading, to actually do the work of fetching and loading in whatever way we define. We just synthesize an HTTP response and pass it in, so there's actually no loading. And then the fourth is cleanup in the event that it's canceled. And so that's the completion of the second step. The third and final step is to make sure that we tell the URL loading system that the application is using, like, hey, this is our protocol that we want to use, so use us. And we do that, this is just a simple app delegate, by telling or calling register class on URL protocol, and then we pass in the name of our class, my cat exterminator protocol.so. And so if we don't register like we just did in app delegate, our can init will not be called at all. So we are totally invisible to the URL loading system if we do not register, URL protocol.register, totally invisible. So those are the three steps to implement the URL protocol. And so the results, this is what I was saying earlier about data task presumption. If we just, typical shared session, we create a data task, and we're going to load google.com/cats, and because we had registered our protocol, we will print the cat status, and Google by default does not return this in their HTTP headers, right? This is totally made by our protocol. We will get exterminated, verifying that our protocol was registered, right? So that request didn't even leave the phone. It was a zero latency, or pretty close to zero latency response time, because we just synthesized it in the protocol, passed it back in, and there's the cat status, it's dead. And so the three steps just to make a protocol: first, you create a subclass, make sure you override the four most important methods, and make sure you register it with the URL loading system. And by doing that, you can go back and make sure that all of the third parties in your app, you can tell what they're sending to their servers in production. You can measure it. You can add performance metrics. You can do really anything that you can do on a proxy server. You could sort of a priori figure out how to do in a URL protocol. And so the next layer down is if you're seriously considering run our URL protocol in production, there are some pretty strange runtime things. And so our use case at Caffeine, which is where I work, is we replace the HTTP and TLS with our own protocol to improve the performance and reduce round trips of network on iPhone applications. And so we use our own protocol entirely. So without Caffeine here, it would be TLS, HTTP, and it needs to be really easy to add. So you can drag in our framework, and it needs to be fully taken care of itself. And we do that through inserting ourselves through URL protocol. So these are some things that we've noticed while working extensively with URL protocol. So again, if you're seriously considering using it, you need to be very wary of what third-party networking libraries you're using, if at all. They don't play nicely out of the box. And also, if you plan on making anything that is a post, or really mostly non-item-potent requests, anything with an HTTP body that you're sending, you need to be paranoid about using URL protocol if you are not just getting things. So it won't work. So with the stuff about HTTP bodies on our requests, they will be set to nil in URL protocol. And so to tell you what that means just totally expressly, we create a shared session, a request, random URL. We set our HTTP body to something, assume this doesn't crash. We always have cat pics in our bundle. We'll set the HTTP body to something. We'll make the request. And inside our protocol from earlier, inside the can init, our request is passed. And our request, as we just created it, has HTTP body set to the cat pics, right? If we have this assertion to make it non-nil, this will crash. there actually is no HTTP body from my cat exterminator protocol's point of view. And so that's a pretty serious bug if your network traffic is being routed through your protocol. And the reason it happens is it's an Apple bug that has not been just been in there. And those are the radars. If you're interested in lobbying and upvoting it, we would really appreciate that. We have not had luck getting Apple to look at this. And what happens is that set HTTP body nil is called on the request before it gets to the URL protocol. Like some Apple engineer left that in there. And the second sort of category of problems that we've experienced with using URL protocol at runtime are with these third-party networking libraries. And it will fail it will be totally invisible for requests that are issued on non-shared URL sessions. And I'll show you what that means, because third parties use their own custom session configurations. So this was our example of loading google.com/cats, all was working well, with a shared session. But if we change it to our default and instantiate a session with a custom configuration, which is the default session configuration, which Almafire and AF Networking both do, it will stop working. So even if we register our protocol in the app delegate, it will still be invisible to a session that is instantiated with a custom session configuration. So it has no effect on this, and as it is never called inside our protocol. And it will crash because we are not inserting the cat status into the request. So we have to add explicitly to the session configuration our cat exterminator protocol. We append it right on there, and all's working well. And the cat will be exterminated, right? But the problem is, we don't typically change the source code of third parties. And if you want those parts to remain totally independent components, you can't actually change the configuration. So our solution was, because you could be using Almafire, you could be using AF Networking or Moya or whatever else. So our solution was to exploit the dynamic nature of the runtime to get our way in there. And are folks familiar with swizzling in here? Did I get a show of hands? Who's familiar with swizzling? Okay, so swizzling, quick overview, has to do with, it's a runtime hack. So at the Objective-C runtime is dynamic. So there is a time where, because Swift runs on the Objective-C runtime, that you can swap the method implementations so that when we're calling, for example, print, if we exploit this notion of swizzling on the Objective-C runtime, we could actually remap all calls to print to calls to network requests, so that when you have a developer who's writing print, he's actually calling google.com/cats and loading it. So this is like dangerous black magic stuff because it actually changes what the source code does. And that's, that might go away if we stop using the Objective-C runtime, but that's the nature of it. And so when Almafire and friends set a session configuration, they will get ours instead. So when they call, and I'll show you right here. So when they call URL session configuration.default, they will not be calling the foundation method. We will swizzle our way in there so that when they call URL session configuration.default, they will be calling our implementation instead, and we will return them the default session configuration with our stuff added into it. So it's a way to sort of get around buggy, compiled third-party code, swizzling. And how we do that is by extending the URL session configuration, and we create a new method that will return our session configuration that is default and that has the cat exterminator protocol added to it. And this is a detail, but it's important. You make sure it's dynamic, that there are a bunch of reasons for that, so that it's a message pass as opposed to a static dispatch like you would have in C. And we will create so if you don't understand swizzling, this looks like an infinite loop, right? Because we're creating a config by calling our function that we are currently defining to get a session configuration. But you have to remember that that is the case at compile time. At runtime, this implementation will be swapped with the default session configuration implementation. So at runtime, the default config with cat exterminator will actually return URL session configuration.default and will not call itself. Right? So swizzling it looks like a bug. Like you look at this and you cry. It's terrible. So that's why you want to use swizzling as sparingly as you can. But it's powerful as hell. So we will then do what we did previously, which is we take the config and we append our protocol to it, and then we return it. So that when any person or any third party calls URL session configuration.default, they will always get this instead, right? And so that we will be able to insert ourselves in there all the time. So swizzling is a whole nother thing that if you haven't heard of it, you should look in, because you can do crazy, nonsensical things and destroy whole code bases and run up the engineering bills for months. So be very careful. And then this will define a function to actually do the method exchange, where we swap implementations, and we do that by getting the selectors, and then we get the functions from the selectors. And then we actually swap the implementations. So we will exchange the URL configuration.default, right, which is what Almofire uses, with our own implementation, right? And we will swap those at runtime. So what looked like a bug, if we were to scroll up, where we're calling ourselves, is actually going to be the default session configuration. And we will, call this function in the app delegate. And then we go back. We don't need to actually change the source code of the third parties. They can call default whatever, and we will have inserted ourselves in there pretty seamlessly. And so that was swizzling rundown. If you're interested in using URL protocol in production, be very wary about it. You have to swizzle. And so URL protocol is very powerful, and it's broadly applicable, as Georgia was saying earlier. It's as easy as subclassing, overriding for methods, and registering. It's sort of prima facie until you want to ship to production. Then you have to worry about the runtime. But it can be solved. And thank you for listening. That's all. Thanks.